In Lab 3, I'm going to be looking at how a sprint during a game of soccer should be completed through a motor learning lens using an athlete who is in the autonomous stage of development. First of all, the athlete must have their body weight in the balls of their feet while creating a low center of gravity. This is achieved by hinging at the hips. Furthermore, in the preparatory phase, the athlete must ensure their spine is neutral with their upper body leaning over their front foot ready to sprint. In addition to this, the athlete must create a slight flexion in the knee joints as this will give them a solid platform to push off. Then, as the athlete begins to sprint, they must create a full range of motion with their arms, moving them vertically in the sagittal plane with a 90-degree flexion in the elbow joint. As we approach the movement phase, the athlete must ensure a low knee drive is occurring, which in turn allows their strides to be shorter. Looking at the athlete from an alternative angle, as we pause the video here, we can see them change direction by creating a low center of gravity. This is achieved by flexion occurring at the knees, lowering their body closer to the ground while distributing their body weight evenly. The athlete also takes a small strides as they change direction. I'm going to break the technique down and explain in more detail what is happening with our athlete. Furthermore, I will provide different areas of criteria that I will use to evaluate the movement mastery of the sprint. The reason for the athlete creating a low center of gravity is because they are reacting to a stimulus such as the ball dropping or a teammate passing the ball into the open space for them to run onto. Then, by creating a full range of motion with their arms while sprinting, this will help to gain speed and also encourage the mechanics of the athlete's legs to be vertical in the sagittal plane. You can see in the video, the athlete is demonstrating excellent knee drive in relation to sprinting when competing in a soccer game, as the degrees of freedom is minimal. However, this benefits the soccer player as it will enable them to change direction faster and more effectively. As the athlete here is in an autonomous stage, they are more developed in their sprint mechanics. However, there are always areas to improve and become faster. One criticism of this athlete is that we can see the athlete's arms aren't moving in the full range of motion and they are moving slightly horizontally, which in turn rotates their upper body and legs. This means that the athlete will become less efficient while losing speed, which is what we are trying to avoid. An effort to evaluate their movement mastery would be watching themselves sprint, looking for errors. This would be the athlete using visual processing to develop their movement mastery. When evaluating a movement, we must also discuss the constraints. First type of constraints are functional constraints, and this is how the athlete feels on the day and how they are in regards to their motivation levels. On the day of testing, the athlete did not complete a full warm-up, so this could have affected their technique and performance. Therefore, if I was to complete this again, I would ensure the athlete took a step-by-step process to warm up correctly. Another area of constraints that must be discussed are the environmental constraints. In this case, it involves the surface the athlete is sprinting on and also the footwear they are using. Within this video, the athlete is sprinting on grass while using football boots, which are designed for enhanced traction. However, if the athlete was sprinting on turf, then they would have greater traction, allowing them to get a greater speed as there is a firmer surface to push them off from. Training my athlete, it would be beneficial to train them on all types of surfaces as this will prepare them correctly and it will ensure their training is specific to their sport. While working with my athlete to help improve their speed during a game of soccer, the drills and training must be specific to the sport. This drill is called the T drill and it begins with the athlete sprinting to the first cone, which is placed 10 yards away. Then they must create a low center of gravity to change direction to the left and sprint around the next cone 5 yards away. Changing direction again, they must sprint to the final cone before sprinting back to the start. This drill is beneficial as it involves many turns over a short distance while aiming for maximum speed. Another drill I will implement into my athlete's training is the W drill, as it involves multi-directional movement aiming to increase their speed sprinting forwards as well as backwards. The drill starts by the athlete reacting to a coach's stimulus and they must sprint to the first cone before backpedaling as quickly as they can. The drill is complete when they have completed the W shape as seen in the video.